Hello and welcome to this Formlabs webinar. Today we'll be talking about injection molded parts. So I'm just going to wait a few seconds and then we'll get started. But please do engage with us and tell us what you're currently 3D printing in the chat at the bottom. Hi, everyone. Looks like lots of you are connecting from different parts of the world today. My name is Nell, and I am presenting today from Formlabs European headquarters in Berlin. My role at Formlabs is MEA Growth Program Manager. Prior to this, I was driving the UK marketing, and I've been with the company coming up to 4 years now. So one of the great parts of my role is I get to work on a lot of really interesting use cases for our 3D printers. And injection molding is something that we've seen a lot more interest in the past few years. And we've really rolled out our solution, enhancing our capabilities on the material side to give you a full workflow that can answer your in-house requirements. So join with me today is Juliette Com. She is an applications engineer at Formlabs. She's been here a little bit more time than me in Berlin, so coming up to 5 years now. And she brings a wealth of engineering expertise. As you can see here, she has an engineering degree and then also a master's in mechanical engineering. So Juliette will be talking through our injection molding solution, but it's also really interesting because she has been working with customers globally on their best practices and workflows, and she'll share them in more detail later. So Formlabs, I don't know if you are already existing Formlabs customers. We probably have quite a nice balance of people who are new to Formlabs. So I just wanted to give you a quick overview of who we are. So Formlabs was founded in 2011 in Boston. It was an MIT founders who decided to create a business to make SLA 3D printing more accessible, right? So it was very expensive prior to this, and they really wanted to kind of democratize 3D printing so that anyone could really create what they wanted to with this technology. So as you'll see the product lineup on the left here for SLA, this includes dental solutions, medical solutions, and then of course post-processing units. And then they didn't want to stop at that. They looked at SLS, so selective laser sintering printing, nylon 3D printing at Formlabs, and they wanted to do the same thing with this and make it a lot easier to use, bring down the price point of adopting this technology. So obviously that's very important if you want to increase adoption. And also just making sure that we have the best kind of service out there, because it is a daunting prospect for many companies kind of changing from traditional techniques. So what is low force stereolithography? I thought for those who have been with Formlabs for some time, perhaps you have a Form 2 or maybe you go back as far enough as a Form 1 Plus. I wanted to just talk about what low force stereolithography is. So this is an enhancement of SLA. And this is really kind of working with a flexible tank and as you can see here, linear illumination to give you the best possible print. So this was from feedback from customers and just from trying to improve the peel friction when you're removing prints from the build platform. And this is something that has really enhanced not only like speed and precision, but also how our customers are using our printers. So we have our full agenda for you today. We will first go into the low volume rapid injection molding, and Juliette will present some use cases. She'll look into the workflow, so kind of what is required to get started. Then we'll explore some user stories from around the globe. And lastly, we'll be looking at your questions live. So we'll go into the presentation of low volume rapid injection molding. First of all, I just want to ask audience questions. So we have a few polls throughout this presentation. First one is around your familiarity with injection molding and whether you have injection molding capabilities in-house. So that will appear on your screen now. Please take a second to just fill in the poll as it pops up. Great. I don't want to take too much time away, so I'll present that to you now. Thank you very much. it looks like there's a real mix here. We have about 40% of you that are sort of intermediate, a bunch of you that are beginners. So we'll try and cover all aspects of this in the presentation. But yeah, like I said, we'll be sharing resources throughout to help you learn more about the process and workflow. Right, so without further ado, I'll hand over to Juliette, who will take you through the rest of the session.
Thank you very much, Nell, for this introduction, and welcome everyone to this discussion around 3D printed mold for injection molding. So I've been talking about injection molding with 3D Print Talk for a while already. We've made a lot of content last year, like some white papers, some user story, and also some other webinars. So if you've already attended a webinar last year, this might be a little repetitive, but we had a lot of requests to do it again and had more time for Q&A as well, and to have also a refresh on the content. So here we go, and we have we're going to have a long Q&A session at the end. So I hope it's going to be very interesting for you. So first, I want to start with setting some context. I see that there are a lot of beginners in injection molding and also a lot of intermediate one. So just a little brief overview of what is injection molding. So this is a leading industrial process for manufacturing plastic parts. It is an extremely repeatable technology that yields to high quality parts, and therefore it is widely used for mass producing parts with tight tolerance. It's also very fast with very short cycle, about 15 to 60 seconds for each cycle. So it is very cost effective for large volume manufacturing. Typically it's about 1,000 to 100,000 of units that are being produced. Cost per part is very low. It's about $1 to $5, and it's like typical thermoplastic that are being produced: polypropylene, polyethylene, ABS, and so on. So how does it work? It's high temperature and high pressure that melt plastic pellets into a rigid mold, and then the plastic cools, solidifies into a final part. So another question for you to understand, for those people who are doing injection molding already today, how do you currently manufacture your injection mold today? So you'll have another poll coming up.
Wait, is there answers coming?
Yeah, answers are coming. So we have a lot of people who are outsourcing their mold. A little bit are in-house CNC machining, so they have the CNC equipment in-house. We have 9% that are already doing in-house 3D printed mold, actually, and then a few percent that are doing others. But the majority is at 66% of outsourcing. So that's not really surprising. Good. All right, so you can see on this picture, this is an example of an injection mold. Typically, if you're using injection molding, you're probably producing your mold out of metal machining, and you're probably outsourcing them then, as we've seen. And tooling production is usually between $2,000 to about $100,000 of dollars or euros, depending on the complexity of the mold, the part geometry, and so on. And it takes about 4 to 8 weeks of lead time if you outsource it. So it is very long delays and very expensive tooling. So usually you get a return on investment on your tooling when you produce large volume, large quantity of unit. So this is actually mass manufacturing, right? But what if you need to produce limited quantities of unit? So this is really the topic of today. Low volume production can be challenging. So if we look at the typical step for product development here on the x-axis of this graph versus the technology available or the technology that are commonly used on the y-axis. So it starts with concept and prototype on the left of this graph, where designers usually use direct 3D printing for prototyping, and then it goes to mass production on the right of this graph with traditional injection molding being cost effective only for mass production, as we just seen before. So how do we do when we sit in the middle, right? In the product development lifetime, there is time when you need to produce series of prototype or pilot runs, and also a limited series of end-use parts. So both technology are not really cost effective today for this kind of demand. So 3D printed mold can actually bridge this gap between prototyping and production. So it's one way to do it. It's what we call rapid tooling. So that way, product designers can produce tools rapidly. This is said in the name. And then, so 3D printing allows to produce rapidly mold, either for functional prototypes, so if you need to test the material before going to mass production, or if you need to test your design before going to mass production, and affordable pilot run as well, if you need to produce quite a lot of prototype, so large quantity of the same prototypes to send in the field for environmental testing and so on, or if you need to do on-demand production for a limited series of unused parts. So I would like to know why today you were interested in doing low volume production. I guess if you're joining the webinar, it's that you have a need for that today. I would be interested to know what is exactly your use case. So you'll have another poll coming out. Okay, so actually the poll now is not really matching the question, but it's still an interesting question. It's asking the volume of production that you're doing or planning on doing with 3D printed mold today. So it's pretty related anyway. It's interesting, I see that 50% of the audience is planning on doing less than 50 parts. So this is, really like for small prototypes and for functional prototype most likely, and then quite 24% between 50 and hundreds of parts, and then after we have another 25% between 100 and 1,000, and then we have almost nobody looking for more than 1,000 parts. So yeah, that's quite interesting. We are really, the majority is under 50 parts. All right, so Nell already introduced Formlabs for those who don't know the company. We are manufacturing desktop 3D printer, and desktop 3D printing is really a powerful solution to fabricate tools rapidly and at low cost, because it is easy to implement and to operate and to maintain. So it requires very limited equipment, and it saves CNC time that if you're using CNC today, you know that it's very painful. You need to program the cam, you need to have skilled operators that are operating the machine. So you can actually save this labor for higher value tasks in the meantime, and use your desktop 3D printed 3D printing equipment to do rapid tooling. So this is really powerful to do rapid tooling and iterate quickly and accelerate your product development, basically. So we are, most of our users are using SLA for 3D printing. This is a picture of our Form 3 and Form 3L. SLA is actually a great choice for injection molding. It stands for Stereolithography, which is one of the 3D printing technology. And it is characterized by a smooth surface finish and high precision that will transfer to the final part. So the molds obviously will transfer all the detail to the final part. So if it's very accurate and very high detail, the final part will be as well. And it also facilitates the demolding. Also, SLA parts are chemically bonded, which gives so isotropy. It is fully dense part, and it helps to produce functional mold. And at Formlabs, we develop high-performance material that can withstand high temperature, high pressure, that will be in the process of injection molding. So this is why this is really what we recommend for injection molding with 3D printing. All right, so now I would like to show a short video that has been made by one of our partners Multiplus using a 3D printed mold. So I'll just run that, and I just want to show you the whole workflow from designing, 3D printing, and then using in the injection molding machine. So they were using a baby plast machine in-house to do about hundreds of parts. So
using 3D printers to fabricate molds for low-volume injection molding can reduce costs, shorten lead times, and help bring better products to market. Founded in 2005, Multiplus provides manufacturing services to over 250 clients per year, many of which require small batch production. We've partnered with Multiplus to walk you through the steps of the injection molding process using 3D printed molds. Begin by designing the mold using common design for manufacturing principles. 3D printed molds can incorporate the same components as metal molds. Upload your design into Preform, Formlabs print preparation software. Prepare your print and send it to the Formlabs 3D printer. Choose a material and begin the print. Rigid 10K resin combines high strength, stiffness, and thermal resistance, making it an ideal material for injection molds. All SLA 3D prints require washing and post-curing to bring parts to their optimal mechanical and thermal properties. In just a few hours, your 3D printed mold is ready for assembly. 3D printed molds are often designed to fit within the standard metal frames, which extend lifetime of the mold. Prior to assembly, you may choose to sand or machine the mold to meet critical dimensions. Assemble the 3D printed mold inside the metal frame. Ejector pins can be added to automate demolding. The mold is now ready to be used. Install the assembled mold in your injection molding machine. Insert the plastic pellets, input the required settings, and begin production. Formlabs 3D printed molds are capable of withstanding hundreds to thousands of shots, depending on the part design and molding conditions. Using compressed air can accelerate cooling time, which is typically longer with plastic molds. Whether you're looking to design functional prototypes with end-use materials, fabricate pilot production parts, or manufacture end-use parts, using Formlabs 3D printers to fabricate injection molds is a cost-effective and quick way to produce parts in limited quantities.
all right, so obviously, there are some consideration to take when you're using 3D printed mold instead of metal mold, because as you can imagine, plastic 3D printed tool is much more fragile than metal tool. We have to try to reduce the impact of the pressure, of the temperature, of the demolding, and just of the some material as well can be very abrasive on plastic 3D printing. So this is what we gathered from different research and customer feedback, different type of recommendation on the design and on the process itself. So we have a lot of different resources that can help you do the process. We have actually even a web page on our website for dedicated to injection molding. Nell is going to post all these resources on the chat. We have an injection molding white paper with design guidelines and method and case study from different users as well. This is more like a comprehensive piece of content, but we also have a short quick start guide, just a few pages that can really help you on the go. And we also have some different user story and an FAQ blog post and so on. So we're just going to post all those resources that can help you in different situations. So first step is to design the mold. At Formlabs, we are expert in additive manufacturing, but we are not expert in mold design. But we've been working with experts in injection molding, and they gave a lot of different recommendations on how to minimize the impact of the pressure in the cavity. That's really like one of the best way to increase the longevity of the mold. So in the white paper you can find a lot of recommendation on, for example, increasing draft angle 2 to 5 degrees, for example, is really the best. Increasing the gate, having a large gate, this helps reducing the pressure. Also having large vents to have a better flow of the material, avoiding thin cross-section, avoiding small feature. As I mentioned, 3D printed plastic tool can be much more brittle, and in particular for thin features. And also, as you saw in the video right before, planning some stock allowance to help meeting both half of the mold together, just to be able to post-treat the mold rapidly after and being able to have a perfect fit and avoid flashing. So those are some helpful recommendations that will optimize your design. Besides that, there are not much more difference between how you design a mold for metal tooling compared to 3D printing tooling. You can incorporate ejector pin, you can incorporate side action core, and so on. We also have a webinar that we've done with design. It's a design masterclass. We've done that with a teacher from a technical college in the US that is teaching how to design injection mold. So to teach that, he actually has been used from free L printer actually, and is just helping his students to understand a bit the process with 3D printed mold. So how to print after you design your mold, you print it. We recommend using the rigid 10K resin, which is one of our resin that is highly glass-filled material. It has very high HDT of 218 degrees C. And so it makes it very thermally stable, but also very stiff. So it's our best material for injection molding. As I mentioned before, you can post-treat the mold either by just grooming it with sandpaper to have a perfect flatness, or with sandblasting also help having a good surface finish. This is already a very matte aspect and very smooth surface finish, but there's always some more we can do. And you can also use some recommendation as printing the mold flat, not using support on the molding surfaces. This is very important. So if you can avoid that, that will really help having a best quality. So we've gathered a lot of different feedback from customer, because the results of using 3D printed mold for injection molding really varies depending on the geometry, the temperature you're using, so the material you're injecting, the temperature, the pressure, and how many parts you're looking for, obviously. So we've gathered a lot of different feedback with part geometry, material here. This is all gathered in a table of process condition. You can also find it in our resources. This is actually ordered by material, so if you're looking for one specific material, you can see if we know a customer that has done it, one of our users that have done it, and how many parts they got. And here I try to just summarize a bit all those findings. And what I really want to stress is that it really depends on the geometry and the situation. So we cannot really say with a 3D printed mold you can do that many parts, or this is the result for sure that you're going to get. It will always depend on the part geometry and what you're trying to produce. But what we've observed is that injection up to 250 degrees have really good results, about hundreds of parts for this. So this is the mold longevity. And over 250 degrees, we've had some result, but more about tens of parts, so the mold will deteriorate much faster. And then we have not tested over 270 degrees. And in terms of material as well, polypropylene, polyethylene, those are materials that are very easy to process and are very easy to process at about hundreds of parts. We have also even thousands of parts for some very simple design with polyethylene, but for materials that are a bit more challenging like PA or PC, we've seen only about tens of parts. So this is like a bit of reference for you to understand a bit what are your expectations and what you can imagine. We've also tested a lot of injected material, as I showed here, but again, this will always depend on your own geometry. So we have the next poll coming up. Oh, all right, so this one is actually the question that we had before, so I think we don't need to do this poll again, so we kind of mismatched a bit the question. So I'm just going to jump into the user stories now. So now I want to show you some concrete part and some concrete example of users that have been using 3D printed mold for the project and for their business. The video that we showed before from our partner MLC Plus was made with rigid 10K mold. It is placed inside a metal frame, so this is really something we recommend as well to absorb as much as possible the pressure from the process. And they injected ABS, but also polypropylene and also some ABS and PC material. They were manufacturing electronic housing, and they were doing that in just a few days. So they've been doing that on the Baby Plas machine, which is a small-scale, fully hydraulic injection molding machine, and this is very powerful machine that is great for low, mid-volume production and up to high-volume production of small parts. This is an example of this is a picture of the design, just to give you a bit of an idea. Another example is from one of our customers, one of our users, the Novus Application, which is a product development firm, and they are experts in injection molding for many years. They've been producing hundreds of bottle caps with polypropylene and PE, and what is interesting is they've been using a 3-part mold with a side action threaded core. So I know that it's a question that comes quite often, if it's also possible to use a side action core with 3D printed mold. So this is a great example, and they managed to have about hundreds of parts with that, even though it's a very delicate part. So this is just some picture of the geometry to give you an idea of what is doable. All right. And the next example is from the company Braskem, which is a material supplier that's fabricated thousands of end-use mask strap in polypropylene within a week. So they were really under time constraint. They were very stressed by time to produce about 1,000 of mask strap for their employees. So this is not prototype, this is end-use part. And with a mold that is very simple geometry though, they managed to produce about 1,000 parts. They were using also an industrial press that is all automated, all electric, sorry. And this is an example of the geometry of the mold. This is also the mold that you can find in the design guideline. They gave a lot of recommendation on how to save resin as well and how to decrease the pressure inside the cavity. And they were only using a mold insert that they slide into the injection molding machine. Another case is from the Technical Center specialized in plastic and composite IPC in France. They injected about thousands of parts of polypropylene with a mold printed rigid 10K, and it's a mold insert that was placed into a frame in nylon. And it's interesting because they also included very fine texturing. So I'll show you more picture. You can see here they've tried also some other material, but you can see here they had some torture parts with different features that they wanted to incorporate and some different inserts. And then they wanted to see the render of a fine texture on the parts. So this is here the mold for rigid 10K that you see with very fine texturing, and on the right the final parts. So they were also injecting in the research center with very industrial equipment. And what I want to finish on is, if you're not having injection molding in-house, and if you just want to get started and are a beginner, you also have solution for desktop injection molding machine. So this company is called Holymaker. They are making very small manual press, very easy to start with and accessible. They are using our printer to produce the mold. So this is also an example of rigid 10K. They've been also using other material, and they produce limited series, about hundreds of parts as well, for their customers to help them develop small series, pilot run, prototype, and so on. So again, another example of a geometry. They've also been producing this kind of face shield clips that you can see here. So some a bit more complicated mold with different part that assembles, and some example of wearable as well. This is an example of a frame for eyewear. And finally, another example of a product development company, Glassboard, that also injects some more complicated materials, some TPUs, that for producing also prototypes, so about tens of prototypes. And they're also using a manual press desktop in their prototyping lab. So they're using a lot of different projects for prototyping, and this for them is a great way to reduce time to produce the tooling. All right, so that was it for on my side. So thank you very much, and I will just hand it over to Nell for the next step.
Thank you very much, Juliette. That was a great presentation. Before I get into the next steps, I just wanted to tackle a few things that have been asked in the chat. So firstly, yes, we will share the recording with you after the session takes place. So we will make sure that you have the option to rewatch or share with your colleagues. And then next, I would like to share on the next slide that we will be reaching out to all of you, either through your Formlabs authorized partner or through our team, to offer you a 3D printed sample, so you can test some of the materials that were mentioned and evaluate the quality of the print firsthand for yourself. So then we'll get into a little tool that we have launched that I think is a really exciting way to look into what Formlabs product offering can give you in the Formlabs side. So we have a materials selector, which you can base on your application, and then it will go through and tell, based on the requirements, so the tensile strength, this type of thing, which material is best suited to your needs. So we have a lot of questions in the Q&A. We'll move on to them now. I will just say before then, we have one more poll, which will launch in about 5 seconds. And this is sort of just so we can get a rough idea of where you are in your evaluation phase, and maybe help connect you to the right person at Formlabs if needed, or through your Formlabs authorized partner. And thank you so much. A lot of people joining from all different parts of the globe, I saw in the chat. So great to connect you all here today. Brilliant. So it looks like a lot of you are just evaluating solutions, which is great to hear. If you do need any more information, then obviously head to our website or to our authorized resellers websites if you do need any more details. So let's get started with the Q&A. We have a lot of different questions here. So I'm going to start at the top. If you do have any more questions now, please if you look at the Zoom toolbar, you'll see Q&A, and that's the best place to ask. Great. So how can we improve the lifetime of molds with rigid 10K is one of the first questions, Juliette. Do you have any thoughts on this?
Yes. Yeah, so this is definitely a question that is at the center of the problematic and what our user wants to know. So one of the first thing to do is in the design, including some design aspect that will really help. So I mentioned it a bit earlier. For the design, we have recommendation from user on having larger draft angle, but also enlarging the gate. This will really reduce the pressure inside the cavity. So for example, the company Braskem, when they were designing those mask strap, they had first a small gate, and they were they were having already good results, but when they enlarged the gate, they had 3 times more units with one mold. So they really managed to increase the number of shots. Also having more vents, and so that's just help having a better flow. So anything that you can add in the design that will help reducing the pressure will be good. And then if you have very fine feature that you cannot skip, obviously if you have fine feature, this is always more tricky. So if you have, for example, standing parts that might break off, you can also try to kind of strengthen that. So if you have for example, a metallic mold, for example, a metallic frame, outside the mold, this will help to strengthen that. And you can also think about having some metal insert inside your mold that can be reused over time.
Thanks, Juliette. And Christopher is asking if Formlabs has a material for fabricating molds that is high temperature resistant and chemical resistant.
If Formlabs have some?
Yes.
Yeah. Yes. So I introduced the rigid 10K material. It's has a HDT of about 218 degrees. At 218 degrees. So it's really high temperature resistance, and we saw that it really goes up to 250 degrees of injection temperature, which is quite high. Because it's a process where the mold is not in long time in contact with the material, the mold doesn't really have time to heat up too much. So that's why we actually can go to very high temperature. And it helps also to try to cool down the mold in between with compressed air, for example. So this is one of the ways to do it as well. But rigid 10K will be our recommended material.
Thanks, Juliette. Someone is asking about the sort of process of fabricating molds. So they're saying it's about the expertise of the machining. Just trying to figure out the question part of this, sorry. Mm-hmm. Do you recommend any resources to build mold making materials in-house?
Okay, so I guess this question is probably coming from someone who doesn't have expertise in injection molding and is trying to get started. So I guess going to expert in injection molding, and there are some companies that are doing consultancy on mold design. So I think this is definitely a great way to start. We have a few design guidelines in our white paper, but this is not starting from scratch on how to design an injection mold. This is just consideration from metal to plastic. So we also, I think we have in the white paper a resource on how to design an injection mold that you can check out. Otherwise, I think starting with asking expert in mold design, that will be a great way to start. And you can also start with easy manual desktop injection molding machine at first. That will be easy to implement and accessible.
Thanks, Juliette. Yeah, I will share the link as well. We have so many resources on the Formlabs website, as Juliette mentioned, and if you haven't already seen in the chat, I've also shared everything that we've talked through today. Okay, so we have a question from Dan asking about shrink rate, or if you apply any scaling to the printed cavity and cores.
Yeah, so SLA resin do shrink after printing, but the problem is we cannot really evaluate how it's going to shrink. So it's actually very complicated to incorporate a proper to plan properly how it's going to shrink. What you can do actually is to print the part first and see how is your dimensional variation from the theory, and then you can plan stock allowance in accordance to that. Otherwise, it's just very inherent to SLA technology that it shrinks, and we cannot really know on what axis it's going to be.
Thank you. And then we have a question from Joe. He's asking if you could elaborate on what you mentioned earlier about using no supports when printing the inserts. How easy will it be to detach this from the build tray?
Okay, so the support for printing, if I understand correctly. So with the SLA technology, it's a resin-based technology, so you have to use support when you print. And obviously, support will leave marks. So what I was saying before is that you should always place the support in a surface that will not be a molding surface, so on the back of the mold or on the side of the mold. Usually, I really recommend to print the mold flat on one side. This is where we saw the best accuracy, and yeah, you will have to use support, but obviously if it's on the back of the mold, you can just detach the support, so it's part of the 3D printing process. You have to remove the support, and then you can lightly sand it to have less mark.
Perfect, thank you. And then we have a question about general dimensional precision and stability that we can expect for parts produced with the 3D mold. So maybe you could elaborate here.
Yes, we've had actually one of our users, a novice application, that has made some study on dimensional accuracy and dimensional stability. So 3D printing mold and SLA 3D printed mold for sure are less stable, less dimensionally accurate than a metal mold, a metal machine mold. So you will have some dimensional variation. As I mentioned before, knowing that, you can plan some stock allowance, and this is really helping to just finish the mold with some very light drilling, for example, in your diameters, or some very light sanding helps to go against this dimensional variation. In terms of dimensional stability, rigid 10K is actually very stable over time. So we've really saw that it's repeatable material. So it has very good dimensional stability.
Great, thank you. Then we have some questions about if it's necessary to do any sanding or any additional post-processing for the molds.
So rigid 10K is a material, as I mentioned, that has glass fiber fillers. So you might have a bit of powder that comes at the surface of the mold, and it's really just because of the chemical composition of the part. And what helps is just to wipe the mold with minimal oil. So this will completely remove the powdery aspect. And sandblasting also help to have a perfect smooth surface. So if you really have high requirement on surface finish and accuracy, I will recommend doing this.
Great, thank you, Juliette. We are coming near to the end of the time, but we do have so many questions open, so I am definitely going to follow up on these questions and get you in touch with the right people to answer in more detail. So someone is asking just generally about larger sized printed molds.
Yeah.
A lot of the examples have been smaller, so yeah, maybe you could speak to that.
Yeah, no problem. We can go ahead a little bit. So for large mold, so far we've had feedback on customer printing with the full build volume of the Form 3, and it prints very well with this size mold. We haven't had feedback yet on customer printing with Form 3L, which is a larger build volume, so it's 5 times the build volume of the Form 3. In theory, large mold obviously will be a bit more complicated, because first the dimensional accuracy will be more of an issue to fit both halves together, and it might be also just more fragile. So, but it's definitely doable. We have. I will be actually very curious to have feedback on that. I cannot give like a final size that works and doesn't work. It's just like user feedback that we gather. But up to Form 3 build volume, we have perfect feedback.
Great, thank you, Juliette. And unfortunately, that is everything that we have time for today. And we do have a few more questions in the chat, so I will be emailing out to everyone after this session. But please do not hesitate to get in touch if you have any more specific questions with your reseller or with Formlabs. And I'd just like to say a huge thank you for all dialing in, and thank you to Juliet for that great presentation.
Sure, thank you very
Hope you
much
enjoyed.
everyone for joining, and thanks Nell.